Hey everybody. This is the first of 5 review sessions, preview videos. The purpose of the videos is for you to put some information into your vocab notebooks so that when we're working on practice exams, you have something kind of to look up. So the first review session pertains to equations, inequalities, and literal equations. This is the review session that I'm not going to be able to be at. And so you're going to want to make sure that you look at the review sessions, the review practice questions from the MathBits Notebook website. So to solve equations, these are the steps that you want to follow. Please remember that whatever you do to one side, you have to do to the other, because we can manipulate anything, but we can't change the value. You want to work on the side with the variable, do the opposites of the operations, and you always want to get rid of fractions. You kind of know this already, but it gives you some words as well as some verbal instructions, along with some vocabulary that you really should have in your brain. An equation is a math problem when both sides have the same value. You want to look for an equal sign. When you don't have an equal sign, it's called an expression. You may want to write that down. An expression is something that doesn't have an equal sign. A variable is a letter, a constant is a number, a coefficient is the number in front of a letter, and reciprocal means to flip the fraction. Anytime you want to pause the video to get these notes into your vocab notebook, I would suggest that you do that, because I'm just going to continue scrolling through. When we talk about solving equations, we learned the see-do chart. If we see parentheses, then we do distributive property. If you see like terms on the left or like terms on the right of the equal sign, then we combine like terms. And then we do what we call VBS, or variables on both sides, where if you see add, you do subtract. You see subtract, you do add. You see multiply, you do divide. And you see divide, you do multiply. We don't usually have to simplify or change to decimals, but sometimes the directions would tell us to do that, and that's where we would add the last step somewhere right down here, is to simplify or change to a decimal. We're going to switch gears now and talk about inequalities. Remember your inequality people from way back. We've written this down numerous times. A solid dot has a greater than or less than symbol that has an equal to underneath. Those deal with brackets, and on a graph it deals with solid lines. Inequality people also deal with open dots, which are not equal to symbols, the less than or the greater than. Deal with parentheses and dotted lines on a graph. Remember, when dividing by a negative, when you're doing an inequality problem, dividing by a negative tells you to flip the inequality. So when we go to the next page, you're just going to copy some examples down that show these steps. So here's some examples. In the first problem, we start out with an equation. We need to do distributive property, which is really distributing of a -1 through that parenthesis. Then we see some like terms. Then we see some subtraction, so we add, and we see multiply, so we divide. So you can go through and copy kind of these examples. Notice this one, when we do our see-do chart, we do not divide by a negative anywhere. Well, we do over here, but the negative is not in front of the variable, so we keep the inequality the same. Whereas on this problem, which is a little bit more challenging, we need to bring the x's. I usually bring them to the left. But notice here there was a negative in front of the variable, so we have to switch the inequality. You certainly can always check your work. Sometimes we have to graph inequalities on a number line. Please remember your inequality people. Remember, an open dot tells you no equal sign, and a closed dot tells you that there's an equal symbol underneath the less than or the greater than. Please pause the video anytime you need to write stuff down and take these notes. The last thing I want to talk about for this particular review session are what's called literal equations. Remember, literal equations are ugly, but I've told you before, it's okay to be ugly. I live with it every day. So in this particular problem, if we want to solve for G, the first thing you want to do, even though the answer doesn't really have things that are going to disappear, we want to multiply both sides by 3, because if we do that, it's kind of like cross multiplying, then the 3 goes away in the denominator. So we're left with f plus g equals 3y. Then what we want to do, if we still want g by itself, so we're going to subtract the f. Notice the answer is ugly, but there's not much more that we can do about that. The second example is the one that we did in our Regents. It's actually a little bit more challenging because we have this fraction out front. Please remember, in order to get rid of a fraction, you want to multiply by the reciprocal. Now, this person that did this multiplied by 2 over h because that's the reciprocal. You can do it in 2 separate steps. Multiply by 2 on both sides and then divide by h on both sides. If you multiply by 2 and then divide by h, you're left with 2a over h. Our job is to get b1 by itself, so we subtract b sub 2, and the answer, again, really ugly. Don't let that make you nervous. In this problem, we want to solve for a. This one is a little bit easier. We subtract r from both sides, divide by b, and you're done. Again, the answer, a little bit strange looking, but works. And then the final example for this type of problem was actually another one taken from a Regents. It's talking about the volume of a tuna fish can, and it gives you the formula, and it tells you to get r by itself. In order to get r by itself, this person divided by pi first, then divided by h, so that you end up with v over pi, then divide by h. Kind of weird. You could put a fraction in a fraction if you want. But to undo a square, then you square root that problem. So again, another ugly problem, but that's what literal equations are. Thanks for listening.